Okay, imagine this for a second. The year is 1926.
Right.
You're in a classroom. Smells like chalk dust, floor wax. But on your desk, there's no tablet, no laptop. There's this heavy, clunky, mechanical beast just sitting there.
Are we talking about Pressy's machine?
We are. It looked like a typewriter had a baby with a cash register. I mean, it was this really crude attempt to automate testing.
Yeah.
You'd press a button, and if you got it right, maybe a piece of candy pops out.
Which sounds so quaint now, doesn't it? But that was really the birth of a whole philosophy.
Totally.
And if you fast forward just a bit to 1954, you get B.F. Skinner, the big behavioral psychology guy.
Of course.
And he rolls out his teaching machine. It was literally a box designed to mechanically feed questions to students.
I looked up photos of those. They called them giant electronic brains. But it feels so industrial.
Oh, absolutely.
Like an assembly line for knowledge.
That's exactly what it was. The goal was efficiency, automation. But it was a one-way street. The machine talked at you.
It didn't listen.
It did not listen. It didn't care if you were bored or frustrated or totally lost.
And that right there is the massive pivot we're looking at today. We've gone from those clunky boxes to systems that can, well, essentially read a student. We're talking about AI that detects engagement, that understands frustration, and adapts in real time.
And we're looking specifically at how this changes the game for students who, let's be honest, the traditional system was never really built for.
Students with neurodevelopmental disorders, or NDDs.
Right. ADHD, dyslexia, autism spectrum disorder.
Exactly. We've got a stack of research here, including some really fascinating work by Barua and their colleagues, that suggests AI isn't just a fancy calculator for these kids. It might actually be the bridge they've been missing.
And it's such a critical topic. I mean, the problem space is huge. Think about what mainstream school actually asks of a child.
Oh, yeah.
It's built on this really rigid set of expectations. Sit still, be quiet, look at me. Focus on this abstract thing for 45 minutes straight.
Which is hard enough for any of us. I struggle with that some days.
Exactly. For a neurotypical brain, it's manageable. But for a neurodivergent brain, that environment can actually make the symptoms worse. It creates this feedback loop of failure.
And the research is clear. While we have things like individualized educational practices, IEPs, they are incredibly resource-heavy.
Color-coded schedules, one-on-one time.
Right. And teachers are just overwhelmed. So the mission for this deep dive is to figure out, can AI actually fix this? Or are we just building a shinier, more expensive version of Skinner's box?
And to answer that, we have to look under the hood, not the machine's hood.
The student's brain.
Exactly.
Okay, let's unpack that, because before we get into the gadgets, the robots, the algorithms, we have to talk about the biology.
We do.
I think a lot of people just assume these disorders are, well, behavioral choices. You know, why can't he just sit still? Or why isn't she trying harder to read?
That is the single biggest misconception. It's not a failure of will, it's a mismatch of hardware. And the research we're looking at highlights some really distinct biological markers for each of these conditions.
So let's start with ADHD. It's huge. Affects anywhere from, 9 to 40% of kids?
Depending on the criteria, yeah. It's a wide range.
And we all know the symptoms. Difficulty sustaining attention, hyperactivity. But what is actually going on inside the brain?
The imaging data is really telling. It often shows a smaller brain volume in very specific areas, mostly the frontal and parietal cortices.
Okay, help me visualize that. What do those parts of the brain? What's their job?
Think of them as the air traffic control tower of the brain.
Okay.
They handle executive function, planning, organization, impulse control. So when a teacher tells a student with ADHD to just focus, they're asking them to rely on a control tower that is physically under-resourced.
So the signals are there.
The planes are flying, but the traffic controllers are missing.
So the fidgeting, the restlessness, that's not them being difficult. It's the brain trying to compensate.
Precisely. It's trying to generate its own stimulation just to keep the system online.
That puts a whole new light on sitting still, doesn't it? It's not a choice. It's a biological hurdle. So what about dyslexia? That's strictly a reading thing, right?
It manifests in reading and spelling, yeah.
Yeah.
But the mechanism behind it is fascinating. The aha fact for me in the research was this concept of neural adaptation.
I circled that term like 3 times. Neural adaptation. Break that down for us.
Okay, so imagine I show you a picture of a cat. The first time, your brain fires up to process it. Okay, ears, whiskers, tail. It's a cat.
Got it.
If I show you that same picture 10 more times, your brain gets efficient. It stops working so hard. It basically says, yeah, no, it's the cat. And it uses way less energy.
My brain gets lazy. In a good way. It conserves its battery.
In a great way.
Right.
But in a dyslexic brain, that adaptation to repetitive stimuli, especially words or letters, it doesn't happen as effectively.
Wait, hold on. So every time they see the word cat or even their brain is processing it almost like it's the first time.
In essence, yes. That energy efficiency game just isn't there.
No wonder reading is so exhausting for them. That sounds incredibly draining.
It is, and that's what leads to the struggles with fluency. It's not that they can't read, it's that the neural shortcut just isn't forming properly.
Okay, so we have the air traffic control issue with ADHD and this energy drain with dyslexia. What about the third group, autism spectrum disorder, ASD? Prevalence is around 2%. What's the biological aha there?
This one is maybe the most counterintuitive. We often think of disorders as, lacking something. But the theory discussed in our sources for ASD involves something called the pruning process.
Pruning, like gardening, trimming the hedges in your yard.
That's a perfect analogy. When a neurotypical brain develops, it creates this massive explosion of neural connections. Way too many, actually.
Okay.
So as you grow, the brain prunes away the connections you don't use. It clears out the underbrush so the main paths are clear and fast.
It streamlines the wiring.
Exactly. But in many ASD brains, that pruning process is reduced. They actually retain those extra connections.
I would have thought more connections is a good thing, like having more RAM in a computer.
You'd think so, right? But imagine a highway system. Instead of a clear freeway from point A to point B, you have 1,000 on-ramps and off-ramps and intersections.
It creates noise.
It creates so much noise. It creates dysregulation. The signal gets lost in all that traffic.
That's a powerful image. So you've got dysregulation, lack of adaptation, structural differences. Standard textbooks just aren't built for that kind of hardware.
Not at all.
Yeah.
And that is where the AI toolkit comes in. If the biology is different, the intervention has to be different. It has to be adaptable.
So let's get into the gadgets. The sources list some really specific tools, starting with ADHD and dyslexia. What stood out to me for ADHD was something called the Watchminder.
It's a great example of a wearable intervention. It's so deceptive in its simplicity.
Right. It just looks like a normal watch.
It looks like a sports watch, but it's programmed with activity and behavior sensors.
Okay.
Think of it as an external supervisor.
Okay.
Remember that air traffic control tower we talked about?
Yeah, the one that's understaffed.
Well, since the student's internal tower is understaffed, the watch steps in. It sends these little vibrating reminders to refocus. It's a memory aid that taps them on the wrist and says, hey, come on back to the task.
I love that. It's a gentle nudge, not a teacher scolding you in front of the whole class.
It preserves dignity, yeah.
Totally.
And then on the software side, you have speech-to-text tools like Dragon Naturally Speaking or VoiceFinger.
Which, I'll be honest, I use sometimes just out of laziness. But
Yeah.
for these students, it is not about laziness.
Not at all. It addresses a physical bottleneck. For many with ADHD, the actual motor skill of writing and the cognitive load of spelling are huge distractions from their ideas.
Right.
By using speech-to-text, you just bypass that bottleneck. The research shows it significantly improves outcomes because the student can focus on what they want to say, not the mechanics of how to write it.
Okay. Moving to dyslexia, the interventions get a bit more algorithmic. The source talked about Detective U.
Detective U is fascinating because it uses what's called a support vector machine algorithm.
Okay, stop right there. Support vector machine sounds like something out of a sci-fi movie. What does that actually mean for the kid playing the game?
It's a fancy term for a classifier.
Okay.
Think of it like a very, very observant coach. As the student plays these cognitive games, the algorithm is watching their data reaction time, error types, hesitation, and it classifies their specific bottlenecks.
So it's not just easy, medium, hard.
No, it's way more fluid than that. It builds a personalized curriculum on the fly. And it does this using deep learning models, specifically CNNs and LSTMs.
All right, alphabet soup, we need to decode those.
Okay, simple version. CNN stands for Convolutional Neural Network. These are the eyes of the AI. They're incredibly good at processing visual data, like the shape of letters or words on a screen.
Okay, CNNs are the eyes. What about LSTMs?
Long short-term memory networks. They're the
Yes, yeah.
memory. They understand sequences.
Okay.
Because reading isn't just one letter, it's about the flow of a sentence. LSTMs let the AI remember what happened at the start of the sentence by the time you reach the end.
So you combine those, and the AI can see how a student is reading and remember where they stumbled before.
You got it. And that's what powers tools like VoiceStream Reader. E-readers are more effective than paper because they can change the text font, spacing, audio support to match that neural adaptation issue.
Yeah.
It just reduces the cognitive load.
That makes so much sense. Okay, so we have wearables for focus, algorithms for reading. But the next section of our deep dive takes a hard left turn into the physical world. We need to talk about the robots.
The social robots.
Hmm.
This is where AI moves from a tool on a screen to a presence in the room.
The cast of characters is great. Caspar, Nao, Milo, and Pepper. But I have to ask the obvious question here. Why? If a child with autism struggles with social interaction, isn't giving them a robot just leaning into the isolation? Why not put them with other kids?
That's the paradox, isn't it?
Mm-hmm.
But if you connect it back to that noisy highway analogy we used for the ASD brain, it starts to click.
Okay.
Humans are incredibly noisy data sources.
What do you mean by that?
I mean, we use sarcasm. Our tone changes. We have microexpressions that shift in a millisecond. If you are struggling to process basic signals, a human face is overwhelming. It's too much information too fast.
And robots are clean data.
Robots are predictable.
Uh-huh.
Caspar, for instance, is a humanoid robot, but a simplified one. He doesn't have complex facial expressions. If he smiles, is it the exact same smile every single time? It provides a safe, low-anxiety space where a child can practice eye contact without the fear of being judged or getting confused.
It's like training wheels for social interaction.
That's the idea. And these robots are using deep learning cameras, mics, to analyze the child's own expressions and posture, assess engagement levels. If the child looks away or gets distressed, the robot adapts instantly.
There's also the wearable side for ASD. That Empower Me tool on Google Glass really caught my eye.
It's brilliant. It uses augmented reality to overlay information onto the real world. So a child looks at a person, and the glasses analyze their expression and literally tell the child, this person is happy, or this person is angry.
A decoder ring for emotions.
And it's effective. One of the games mentioned, Emotify, achieved 72% accuracy in emotion recognition. That's a massive leap.
Wow. Now, we have to talk about the students who might not be able to speak at all. Section 4 covers nonverbal students and what's called AAC.
Augmented and alternative communication.
Yeah,
this is an area where traditional methods were really lacking.
We use picture cards, right?
Picture exchange systems. Physical cards, you want an apple. You flip through a binder, find the Apple card, hand it over.
Which works, I guess.
Yeah.
But it's so slow.
Yeah.
And static. If you lose the card, you lose the word.
And your vocabulary is limited to the cards in your pocket. AI changes this with natural language processing, or NLP. Tools like the OTTAA platform don't just act as a library. They predict what the user wants to say.
Like predictive text on your phone, but for your entire thought process.
Exactly. They allow for manding, which is the term for requesting, and tacting, which is labeling things. Because the AI learns the user's habits, it reduces the effort needed to communicate. It gives a voice to someone who was locked in silence.
That is the promise we talked about.
Right.
And there's always a but. We have to look at the future vision and the risks. The Barrow paper proposes something massive. A cloud-based AI system.
This is the logical next step, but it's also where the ethical ice gets very, very thin.
So instead of individual devices.
The idea is to move to a centralized cloud server, a hive mind in a sense.
Okay.
Imagine if every robot, every smartwatch, every tablet in every school sent its data to one central server. The AI could learn so much faster. It's processing images, biosignals, learning history, all of it.
And for schools, I'm assuming this is cheaper.
Much cheaper. You don't need supercomputers in every classroom. The heavy lifting is done remotely.
But just pause on that for a second. The data we're talking about here, it's not just test scores. It's biometric data, emotional states, behavioral struggles.
It is the most sensitive data imaginable.
If I hack the bank, I get credit card numbers, I lose some money. If I hack this cloud server...
You have the psychological profile, the real-time location, and the emotional triggers of vulnerable children. It's a massive honeypot for attackers.
That is a nightmare scenario. Do the sources offer any solution?
Well, they talk about decentralization. Basically, never keeping all the data in one place, splitting it across the network so there's no single point of failure.
But even with that, there's the legal side, COPEC A.
The Children's Online Privacy Protection Act requires parental consent for anyone under 13.
Yeah.
But informed consent is so tricky here.
Right.
If a school sends home a permission slip for an AI learning companion, does the parent really understand what that means?
That an algorithm in the cloud is analyzing their child's face 30 times a second? Probably not.
And does the child understand? It raises huge questions about autonomy.
And there was a brief mention in the sources about the human cost, about chatbots replacing counselors.
It's happening. With shortages of school counselors, chatbots are being used to fill the gap. They're a judgment-free zone, which some students like, but can an algorithm truly empathize? Can it care?
So where does that leave us? We've gone from Skinner's mechanical box to emotive robots like Caspar, and now to this theoretical cloud brain that knows how you feel before you do.
I think the key takeaway from all this research is that AI is a bridge. For the ADHD student, it bridges the gap in executive function. For the ASD student, it bridges the confusion of social signals. For the nonverbal student, it bridges the silence.
But the bridge itself isn't the destination.
No, the goal is to free up the human educators. If the AI handles the data, the pattern recognition, the rote repetition, the teacher is free to do what humans do best.
Connect, encourage, inspire.
Exactly.
That's a hopeful vision. But I do want to leave you with one final thought to mull over. We talked about this cloud system, this black box, that translates the world for a neurodivergent student. If the AI is the bridge between that student and the world, who is interpreting the translation.
And on a practical level,
Yeah.
what happens if the internet connection for that cloud server goes down?
Is the bridge just lost? Something to think about. Thanks for diving in with us.
It was a pleasure.